Okay, guys, so I'm going to teach you about lipids now. We talked about the other biological molecules. Now we're going to talk lipids. Lipids are not considered polymers. They're not considered polymers because they don't just repeat all the time, the same units all the time. They repeat with different things. Their main function is to store energy. They work in all of your metabolic activities, and they are a major component of your cell wall, or cell membrane, not wall, excuse me. Amphiphilic is a molecule that has a positive and water-loving and water-hating end. The heads are usually, in this case, a hydrophobic, so it is water-hating, and this one side is hydrophilic. So that's what amphiphilic means, and we're going to use it in a minute. All right, triglycerides. Triglycerides are hydrophobic. They do not like water. They are constructed from two smaller molecules, a single glycerol and 3 fatty acids. So here's my single glycerol and my 3 fatty acids. The fatty acids are carboxylic acids with very long chains of carbon atoms, and they vary in length and number of locations of double bonds. This one has 1 double bond. The double bonds are going to be important when we learn more about it. So here's a fatty acid. It is going to be hydrophobic. It is nonpolar. So you add the glycerol to it, and you have your 3 fatty acids attached to your glycerol, making triglycerides. And these are going to be a lot of the fats. You know your triglycerides are high. If you get your cholesterol taken, it's going to be a bad thing. The next type of lipid is the phospholipid. The phospholipid is the main component of your cell wall. Cell membrane, sorry guys. It has 2 sides. It has the head and it has the tail. The heads are very water loving. They are polar and they love to attach to water. So they are hydrophilic. The tails are water hating. They are nonpolar and they are not going to want to attach to water. Therefore, the phospholipid is amphiphilic, and that is going to be very important in the structure of a cell membrane and how a cell functions. Steroids are lipids with a backbone that makes these rings. Cholesterol is an important steroid. So you have cholesterol, you need your good cholesterol, you need your bad, and you have your bad cholesterol. They're important in male and female sex hormones. The steroids are important for your testosterone and your estrogen. So, lipids, can they be hydrophilic, hydrophobic, amphiphilic, hydrophobic and amphiphilic, or hydrophilic and amphiphilic? Get your answer. Did you say D? They can be hydrophobic or they can be both. Good. A phospholipid is an example of an hydrophobic molecule, hydrophilic molecule, or an amphiphilic molecule, or a hydrophobic and amphiphilic molecule. Did you say C, an amphiphilic molecule? Good. Phospholipids are amphiphilic. So I'm going to go back and talk a little bit more about the double bonds for triglycerides. You know you can have your saturated and unsaturated fats. Ones that are saturated are going to have hydrogens all the way around them. Because they have hydrogens all the way around them, they are very straight-chained. Being straight-chained means they easily stick to other things. These are going to be your animal fats. It's going to be the lard and things like that that have that nice straight chain, so they stick specifically to the walls of your arteries. If it has a double bond in there, then it kinks. It is unsaturated. It could actually fit some more hydrogens in here if we made that a single bond instead of a double bond. Because it is unsaturated, because it kinks, it is actually much harder to stick to things, making the unsaturated fats more healthy. So that's it. Today we talked about lipids. We talked about the different kinds of lipids, triglycerides, phospholipids, and steroids. We talked about being hydrophilic, hydrophobic, or amphiphilic, and we talked a little bit about the functions. And that is it. We'll move on with the rest of the unit later. Have a great day.